Modulus functions. So for modulus functions, let's say you have, for example, been given fx or x fx is equal to x modulus of x. So what this means is that you're going to have x, the condition that x is greater than or equal to 0, and just have negative x, condition that x is less than 0. So what modulus says is that anything that's been put in a modulus means that it will always be positive. So if something is going to be positive, meaning you can put a negative there and it will be changed to positive, and if it's positive it stays positive. So that's why this kind of makes sense, because if you put a negative there it will become positive, and if you put a positive there it stays positive. So let's say we've been given fx is equal to over x. So even this one means equal to 1 over x, should be greater than or equal to 0, negative 1 over x less than 0. Let's try to graph this one first. So to graph this one, we would first need to give ourselves as like a scale or x values of x. We can just come up with any, so we can say 1, 2, 3, 4. And if x is 1, y is also going to be 1, because this is the same as y is equal to modulus of x. 1, y is 2, 3, and 4. So plotting this, we're going to say, okay, x is 1, 2, 3, and 4, and y is 1, 2, 3, and 4. So plotting the graph would be like this. So it would go like that. The one is, it would go like that. And for the negative x, again we'll put negative x here, negative, negative, negative. Y still remains positive. It's going to be negative 1, negative 2, negative 3, and negative 4. So this is how our graph would look. Let's see how the graph of so let's try the graph of 1 over x. So we come up with x values 1 over x, so it's going to be x, y. I've got 1, 2, 3, 4. So if we put 1 there, y is going to be 1. We put 2 there, y is going to be 0.5. We put 3 there, y is going to be 0.3. We put 4 there, y is going to be approximately 0.25. So our graph is going to be, we've got 1, 2, 3, 4. I've got 1 there, got 0 0.5, 0 0.3, 0 0.25, 0, 1, 1, 1, 2, 0 0.25, 0 0.5, 3, 0 0.3, 4, 0 0.25. You can see that the graph is going like this. So you can also see that the other half of the graph is going to go like this. So let's say we've got an equation like this. That says x plus 1 and there's a modulus here. So what this means is that first we're going to make this into a piecewise function. It's going to be x plus 1 minus, it's going to be x plus 1. The condition that, into the piecewise sign, condition that x is greater than or equal to 0. For this one, x is less than 0. So this one is in brackets like this. And let's say we have another one which is like 2 or 3. Let's say 3 plus the modulus of x over x. So for this one, the modulus is only on x. So meaning, make the piecewise, it's just going to be x and negative x, condition that x is greater than 0 and x is less than 0. And therefore, this equation is going to be 3x plus x over x, and the second equation is also going to be 3x minus x over x. So what I'm showing you is exactly how to handle how to deal with the modulus part of an equation. You've been given an equation and there's modulus depending on what the modulus is. So like for example in this situation it's only on x, so meaning this, you're going to have two equations where only the sign of the x changes, and if it's taking up the entire equation like this one, then the sign of the entire equation changes like this.